So welcome everyone. This is the Quant University Spring School series. My name is Sri Krishnamurthy and I'm going to be the host for today. As always, so we've been hosting these lecture series for the past year or so. And we have had more than 40 speakers from throughout the world come in and join us and present all the amazing work they've been doing. We have had academics, we have had industry participants, we have had students, and they have all shared amazing work in the context of machine learning, artificial intelligence. And primarily, we've been looking at how these technologies can be adopted responsibly within the financial industry. So we have had a lot of themes in the context of explainability and productionizing machine learning based applications, and also looking at this whole notion of model risk and what are the various innovations which are happening in this space. So in that realm, I hope these sessions have been helpful, and I welcome you again for the session. And as we were just discussing, we have more than 10 countries represented in this webinar, and we are also going to be streaming this live on YouTube and on LinkedIn. So if you don't get a chance to catch the whole session, you'll be able to watch the session. So let me briefly introduce a couple of things for people who are joining us new. So Quant University has been hosting these sessions, as I mentioned, for the past year, and we're based out of Boston, Massachusetts. We focus on the intersection of data science, machine learning, and finance. We do a lot of programs in the industry, both in a B2B capacity, but also we have opened up multiple programs in the online world. And we have also been building what's called as the Q Sandbox, which is a platform to enable either rapid prototyping of applications or for various use cases like algorithmic audit automation. So we have hosted the Spring School since January, and we have had more than 10 speakers talk about various aspects. And we have also been offering various courses in partnership with Premier. And we have been very fortunate to have people from various parts of the world take these courses and augment their learning through some of the programming we've been building. And we have added a couple of new courses with the Premier catalog. So we have courses which you can take on a self-serve basis. You don't have to attend all the lectures live. So it's all readily available with all the labs which you can access through the Q Academy platform. So another two new courses we have offered this time along is one is a course on algorithmic auditing, another one on risk and machine learning models. So which is a course which will help you kind of think about the various kinds of tests you have to do in the context of machine learning. So in that realm, I was looking at various packages and various software tools which are available in the context of looking at how machine learning models perform. And I came across this company called evidently.ai. Elena and I, we had a brief chat, and I was very impressed with the work Elena and Emeli are doing in building an open source package for productionizing machine learning software. Both Elena and Emeli have done amazing work in basically simplifying the way you look at the various concepts of drift and the issues you deal with productionizing machine learning applications, and they have built some really cool tutorials. So I thought I'll invite them today to present their work and talk about the various cool projects they've been working on and what their vision for their company is. So just before we hand over the stage to them, I just want to let you know that next week we have Oogie Doig, who's also building an open source platform for explainability, and he's going to be talking about his project. And then we have Jacopo Tagliabue from Cobio presenting the week after, and he has been building some tools integrating model cards and a couple of tools on the Netflix ecosystem, and building a lot of open source based tools to build documentation for DAGs in a production setting. So some really cool things he's been working on. So if you missed any of the prior lectures, you can go to q.academy and you can catch up all the prior recordings we have had so far. And we will hand over the stage to Emeli and Elena now. So Emeli and Elena, take it away.
Hi there. Thank you so much for a very nice introduction. And I feel that the topic we're going to be speaking today is very well connected with what you mentioned. So all the notions of risk and model productization. So myself and Emily, we are the creators of Evidently. And this is a young open source tool in active development. Prior to that, we spent more than 7 years creating applied machine learning models in different industries. So everything that we do is largely based on this experience, and we're happy to share it with everyone. So let me share the screen to start. Can you see it, right?
Yes, we can see it.
Okay, sounds great. So today we're going to have a presentation made of two parts. So first, I will share some more general introduction to what model monitoring is and why we should even care about it. And then we'll have a code-based tutorial that Emily will present, where we will describe it in more down-to-earth terms, how exactly to do this. So I think it will help make it interesting for everyone, whether you're coming from a more managerial background or from more applied data science. So let me start with this very simple slide. Very often when we talk about machine learning models, when we write some content, when we discuss how we're going to create these models, we sort of stop at the deployment. So we think about what is the task we are solving, what is the algorithms we're going to apply, but somehow everything that happens after production is an afterthought. I understand that this is not true for this particular audience, and that sounds great, but still it happens in real life. So only after you actually create the model, you start thinking how we're going to operate it. And there are a lot of things that are happening after this deployment phase. And I would argue that this is actually the most important phase, because finally we're deploying the model in production. We're going to actually use it. It's going to generate business value. And if it does not, it can actually harm the business, or it can lead to certain risks come true. So it's very important to think it as a holistic system where we're going to be keeping an eye on how the model is actually doing and feeding back this insight in, for example, updating our model and making it better or correcting some issues that might occur. So model performance monitoring is a particular step in the process, and that's what we're going to be taking today about. One might think that because monitoring doesn't sound too exciting or too new, that existing approaches related to software monitoring should also apply here, which is partially true, because the models we create, it is still software. You still have to monitor all software-related issues, uptime, memory utilization, speed of response. So everything is related to how well the software piece is performing. But machine learning models, they have more components. So first of all, they made out of data. So we have to keep an eye on this data that is continuously coming into the model, on all the changes that might occur, be it quality issues, be it actual changes in the distributions. And a large part of risks are related just to that, so to the data that is coming into the model. And lastly, machine learning models by themselves, they're a very particular type of software. They can make mistakes by design. They are not just based on rules that you can easily check that they are performing correctly. So there are a lot of things that to keep an eye here. So in the end, machine learning model monitoring requires a little bit different approaches, maybe amended approaches based on our existing software practices. And this is something that we hope the industry will be building up together. But right now, most of teams that we speak, they're solving it in a very custom way, just because everyone is approaching this task for the first time at some point. So let's discuss about a few issues that can occur when your models are in production. As I mentioned, number one is the data quality issues and data integrity issues. I've recently read and watched a very nice talk from Google when they tried to analyze 15 years of machine learning failures, and a large deal of them was just related to the input data issues. So something like you lost access to the source, or there is a broken pipeline. Maybe if you're dealing with the physical world, like manufacturing, there can be actually the loss of the actual device that generates the data, such as a sensor. So all this, if happens in production, this leads to the outcome that the model does not get the data that it should, or it gets corrupted data, or it gets late data, so it cannot properly generate the response. And you should notice this on time, because if it does not, it will just continue generating the output as well as it can, and kind of like cascade it downstream. One particular issue is when you have several models depending on each other, and the output of one model is the input to another model. This again can lead to like cascade of errors if something happens upstream with the data sources. This can also be some very manual errors. For example, if you have some change introduced at the data source, maybe you are like using data that comes from your CRM system, and there was like some schema change introduced by someone, and if you're not properly monitoring all your data sources or data in the input to the model, this will lead to certain issues. Then we have a thing called data drift. So data drift is probably now quite widely spoken of. This is a situation when we see a change in the input data distributions. So imagine you have a marketing model that predicts the likelihood of conversions or predicts churn or anything related to the users or customers that you have. And now all of a sudden you have customers that are coming from a different channel, or maybe from a different geography, or have like very vastly different attributes, demographic or something else, compared to what your model has seen in training. And in general, the model will probably not notice this unless you introduce some checks in the input of the model to detect this. So it's very important to keep an eye on the inputs data, understand when it changes sufficiently, and react to this, because otherwise you might see a decay in the model overall, or you might not notice it if you have some delay in response in how you actually collect the ground truth labels. And this will lead to quite significant losses in between. One particular issue that might happen is when you see the performance of a model drop on one particular segment. This is actually very important at this stage of validation too, because sometimes if you only look at one aggregated quality metric, you might not notice that there are some segments in your data, maybe your premium customers, or again, customers in a specific geography that are where the model performs significantly worse, but it is disguised because the overall quality metric looks fine. So it's very important to approach the model evaluation understanding these nuances. So you either already know some segments which are important for you, so you should check how well the model performs on all the slices of data, or you can use some methods to try to proactively identify the segments where your model does not perform. And of course, it makes sense to track this in production too. There is one more thing that is sometimes mentioned and related to this context, which is called a training serving skill. I would say it's different from that data drift, because here we talk about a situation when the model was created using data from a different distribution, and when the first time you try to apply it to the real world, you kind of notice that the quality is not what you expected. And this happens to the best of us. So here's again an example from Google, where they created the model related to a retina scan classification images, and it was created in a certain data set, but when put in production in specific hospitals, they noticed that the images are actually very different to what the model was trained on. So this asks for very important attention to be paid towards construction of this data set. So it should be very intentional. You should understand how well it represents the world where the model will be working. And then there is one more thing called concept drift. So if in data drift we spoke about the situation when the input distribution changed, here we talk about a situation when the relationship between the features and the target change. So literally something changes in the world, the new patterns appear, or old patterns disappear, and this affects your model performance. So this can happen gradually, and this is sort of normal. So we can expect that many of our models will decay and get worse with time. You can even estimate it if you look at your historical data. You can sort of assume that there is some normal speed of decay and factor it in. So we're going to retrain your model monthly, daily, yearly. It depends on the process. Some can be more stable than others. But this is a normal thing. We can prepare for it. And then there are the things that we have all witnessed in the last year, which is called sudden concept drift, something like a pandemic or any kind of major event that affects all your patterns and thus makes some of your models obsolete, or maybe makes their quality drop significantly. So we witness this a lot in retail types of models, in banking models as well. So you can just see that the models that were trained on a specific part of history do not perform now in a situation which is a little bit different and challenging. But this sort of concept drift might happen not necessarily when you have some like global pandemic type of event. It can be you redesigned an app So now the actual information about the clicks and what you do in the app are irrelevant and obsolete. Or maybe you had a revamp on the production line if you're working with manufacturing models and so on. And then there are issues of bias and fairness and all the potential negative effects from the model applications when it can disproportionately affect different groups. And I think this is like a completely different and very important topic. And we should not only say that it's a monitoring related topic, because you should not catch these issues in production. You should actually detect them during your model validation, understand the risks that the model application might pose, and maybe not deploy some of the models at all, or deploy them with very significant guardrails. But the idea is that even if you do this right, even if you perform the model evaluation correctly, this might change in production because the input data change, because something else changes. So you should continuously monitor metrics that might, for example, show the disparity in outcome or any other fairness metrics that are important to you. Let me make a few more comments about what makes model monitoring hard. So you can assume that all these issues are quite specific, and they ask for careful construction of approach of how you're going to monitor your model. One thing is that it's still a very nuanced thing. So there is like no arguably good and bad model that you can universally define. So just like model evaluation, model monitoring should relate to the task at hand, to your data set, and requires judgment from data scientists. One simple example could be that not all data drift is created equal. So of course, the drift in important features matters more than drift in just features that are secondary to your model. So you should not just like react to any change in distributions and rebuild your model. So you have to factor in what are the metrics that you're checking for and when you should actually intervene in your model. Second is that in many cases, you do not have the ground truth labels immediately available. Sometimes you don't have them at all. Sometimes they're available with a delay. And in these cases, you have to monitor your models using different proxy metrics. So just by looking at the data that gets into the model without the ability to calculate, for example, the error. So it asks for a particular approach how you're going to implement this. And lastly, it is a team sport. So just like here, we are sharing the scene with Emeli. She's a data scientist. I'm coming from the product and business side. And together, if we work on a different project, each of us would have their own interests and understanding of the problem at hand. It's very important to connect the model performance to the business metrics. Not always straightforward. Sometimes you have to deal with some proxies and estimations. And this makes it's essential to build a team and a process around model maintenance and monitoring that involves experts from all sides of the business. That's all I wanted to present for you today. And now we have demo time where Emeli will show in a more specific manner how you're going to do this.
Yes, thank you so much. And I'm going to share my screen right now. And hopefully you guys should see my screen now.
Yes, we can see it. Yep.
So I just opened my Jupyter notebook, so you can see the code in terminal. And I have prepared the very interesting case. I believe it's forecast for bikes rental. Using this data set, the data is open. You can download it from UCI repository or Kaggle repository, what you like more. We are going to build a model that predicts demand for bikes based on the seasonality data about time, data about weather, and we are going to create very nice interactive dashboards to figure out what is happening with the model, is model still correct, and so on. And first of all, we need to load some libraries. I'm using standard libraries like Pandas, NumPy, scikit-learn. And I'm also importing Evidently. This is our tool that we are building together with Elena. And this tool helps us to build interactive reports about model quality. So I'm using virtual environment, and I suggest you do the same, especially if you are playing with some new tools like ours and not ready to install it globally for your laptop. Then, for example, using virtual environment might help. So, okay, let's start doing this. And I'm loading the data. It's the data about bikes rental. I'm using Pandas data frame to read it, and that's how our data set looks like. So this is the table data, and I'm using datetime column as an index because it's quite convenient to do selection on such types of data. So that's the features we have. It's season, holiday, working day, and weather, and all the other information describing the situation in the city. And to analyze the model, we first of all need to build it. So let's start from exactly this. First of all, I need to add some more features because we know that pretty much all tasks where we need to forecast demands to something have strong seasonality. And this is why I suggest to add features like months, hour, weekday to our data. And it's very easy to do with help of map function. We apply it to our index because our datetime is now an index, and we just take months, hour, and weekday. So that's it. And that's how our data set looks like now. And now we can move to model training, and I'm intentionally skipping the part of experimenting there. And I'm just building a very simple model. And of course, if you're up to build models that you're going to use somewhere, you need to perform the standard steps like splitting your data into holdout data set and training data. And it's better to use cross-validation over the training data during the parameter searching and so on. But I'm just will split my data into two parts, train and test, and train my model on train part. So the target will be feature, column called count. I will have prediction column, and I will have some numerical and categorical features. So, and now I'm going to split my data. So reference will be data from January, it's just 4 weeks. And my production data will be data from the end of January to the end of the February. And I said, okay, we have a lot of data. Why do we train model just on 4 weeks? And again, here I'm doing it intentionally because I want to demonstrate how we can see some specifics of model behaviors trained on a very small period of time. Yes, I'm talking about seasonality. So let's do it. We used data as an index, so that is why we can just write log here and put the data we are interested in. And that's how our reference data looks like. So now we have everything to train our model. Let's do it. And for training, I'm going to use a random forest regressor. This is the random forest. It's ensemble over decision trees. And I believe everybody know that it's a very standard algorithm, and it's not tends to overfit. So we can just limit the algorithm and number of trees and do not do a lot of parameter searching. So let's train our model, call method fit, and that's it. It's pretty fast because we have a very small data set, and that's convenient for now. And as I already have a trained model, now I can generate the predictions, and I'm going to generate it for both training and testing data. It's reference and production here. And to make a prediction, I need to have numerical and categorical features. So let's generate our predictions, and let's add it as a separate column to our data sets. So for reference and for production. That's it. And that's how our data looks like now. We added additional column called predictions. So now we have two data sets, and we are ready to start our analysis. So again, in the reference part of data, I trained the model, and the production data, it's a testing data where I apply the model trained on the reference. And let's start to analyze the performance of our model. Here we are going to create a dashboard with help of Evidently, and to make it correct, we need to tell the tool some information about our data frame. So first of all, we need to say where is our target, where is our prediction, what features are numerical and what features are categorical, right? So, but we already have all these variables, and we can just easily come up with such column mapping dictionary. Now that's it, and we need to create the dashboard object. This is pretty straightforward. We use the dashboard that we imported at the very beginning, and now we need to add some data to our dashboard. We are starting just from reference because our first step is to evaluate the quality of our model on top of the training data set. So we do not pass anything as a production data. Here is our column mapping, and here we can choose which kind of report we are about to build. Now we are analyzing the quality of regression model, so let's build a regression performance tab. So I'm generating the dashboard. It takes some time, but hopefully it will not take too much time, right? Yeah, it's ready now, and we call method show to see what's happening with the model. So now it's loading, and that's it. Here we see that our target column called count and some information about the quality metrics. We have a regression problem, and you can see mean error, mean absolute error, and mean absolute percentage error. And for our case, this is a pretty good quality on training data. So in general, our error is quite small. We can analyze some plots like predicted value against actual value, and you see that we have very nice diagonal cloud, right? So it means that our predicted value almost equal to our actual values for pretty much all the objects, which is nice. And we can analyze very same data here in predicted versus actual plots in time, and you can see that, right, we are very close to the actual values. So we can zoom in and see it in more details, and you can see that model actually follows trend very well, and in terms of absolute error, it's also quite good. We have many additional plots here, so we can see the percentage, the error, we can see the absolute percentage error, it's also quite good. And you can see the distribution of error. We see that our model is symmetric, so there is no tendency to overestimate or underestimate the target function, which is quite good. And you can see that the error is more or less normal, which is also shows that model performs well, at least on top of our reference data, right? And you have some more additional information, like predicted versus actual per different groups. But we are not going to analyze it in a lot of details because it's already more or less obvious that our model performs well on top of our reference data. But okay, let's assume that we have that the first week of our model application has passed. Now we have data from the first week of production usage of our model, and now we can generate report for the first week. Just one more comment about the dashboard. If you prefer to analyze your dashboard separately as an HTML file, for example, for sending it to someone or just browse it in a browser, then you can, instead of show command, use here save and create the file with your report. But now we're using Jupyter Notebook, so I'm not going to run this command, but I'll just put it here. Maybe someone will be interested in this scenario. So, okay, moving for our first week. And for doing this, we need to add for our dashboard information about the production usage, of course. And let's do it. We already prepared the data frame called production, and let's log our first week from the end of January to 7th of February. And again, we use the same column mapping because the structure of our data frame hasn't changed. And we again build regression performance tab. So let's run it. And again, run show command to see what's happening inside of Jupyter Notebook. So yeah, the first part of our report is the same because that's quality over the reference data, the data we used for model training. And here we have the quality for first week of usage. So we can see that error gets higher, and that's exactly what we expected to have because, well, that's data that model haven't seen, right? And that's new data for a model. But anyway, we can see that quality is not bad, right? So our mean absolute error is equal to 15 bytes, and this is same more or less okay for our case. So yeah, now we see that our predicted versus actual on production data is a bit worse comparing to the reference data set, but it's again expected behavior. And yes, we can see that model still follows the trend, right? For example, we can see it here, but sometimes the actual values are a bit differ from the predicted. So yeah, that's what we have for our first week. Let's continue our analysis. we can see that error distribution is starting to move a bit to the left, right? So it's a bit shifting and tends to underestimate, the actual values, but that's the highest value is still is 0, so our model is more or less symmetric. So, okay, let's move further. And together with the regression performance tab, we can plot something more interesting. For example, we can calculate the numerical target drift because, well, we see that our error starts increasing. So maybe the reason is target drift, right? So maybe our target function is changed a lot comparing to training data. So let's create the dashboard. For doing this, again, we build object dashboard. We pass the data here, reference and production data frame, same column mapping, but here we have another tab, right? Before we had the model performance, regression performance tab, and now we use numerical target drift tab. So let's do this. And let's show our plot. And that's what we have here. First of all, we are analyzing the difference between our target over reference and production data. And we can see that the target drift has not detected, right? So p-value is quite high, so we cannot detect data drift. We can visually analyze our distributions and see that they look more or less similar, right? So here we have correlations between target and other features we have in our data set. You can see the visualization of target over the reference and production data. And we see that, yes, target on the reference and on production looks more or less the same. So no target drift. And it looks like we can probably continue using the same model. There is no immediate need to retrain it or maybe doing something because it works more or less well. So, okay, let's continue and do this. So we also have the information about our prediction distributions. There is no prediction drift also. So the distributions of predictions over the training data and predictions over the production data are more or less the same, right? So no drift here. And again, correlations, predictions, values, similar data, but not for target, for predictions. So yes, the conclusion here is that we can continue use our model because the quality is comparably good. So now let's see what will happen on the second week. For doing this, we save our reference data, but for production, we take the second week, right? So now we start from the 7th of February and finish at the 14th of February, right? And here we have regression performance tab because we are evaluating model's performance. So we build dashboard and show it. It's loading. Yes, here it is. So we can see that our error getting a bit higher, but it's still within the expected range. So we can see that predicted values against actual values are a bit worse, but still looks more or less normally. Let's continue the analysis, and we see that model continue follows the trend, right? But the difference between actual and predicted data gets higher. So, okay, that can show us that maybe something is happening, right? So probably the quality of our model getting worse, but let's continue our analysis. Let's see the distributions of error. And yes, now we can see that the error moving to the left even faster. Okay, so we can continue our analysis and maybe try to figure out what is happening with the target function because, well, we can see that the errors getting higher, that model now tends to underestimate the target function more. So let's compare our target functions. I'm going to do it with help of the numerical target drift tab, but now I created for the second week again, and let's see what's happening. And here target drift is detected, right? So we can see that the p-value is quite small and we can statistically detect target drift. So this means basically that our target function has changed. And we can see that our target function on top of production data, it's plotted with red color, sometimes get much higher, and we haven't seen such values during the training data. So maybe this is the reason of target drift. But okay, we can see that our target has changed. Now let's quickly see on our predictions. So moving there. And this is interesting, but there is no drift in predictions. This means that our model probably is not that good in terms of making predictions for newer data, because it behaves more or less the same on our new data, and probably it cannot account for the newer data we have in our production. So let's see how it looks like. Yes, you see that on top of production data, our model behaves more or less the same. So maybe our model has some issues with extrapolation. Let's see it. So here we have the table called target or prediction behavior by feature. Let's open it and see what we have here. Here we have plots which shows us how our target and prediction data looks on top of different data set. So now let's scale it a bit to have the different scale over the equal scale or reference and prediction. And maybe there will be some hint on what is happening. And here it is. We can see that in our current new data set, there is some more information about values where we have higher temperature. I mean, during the training data on reference data set, there were no examples of the days where we have temperature higher than 20 degrees, but in our current data, on our second week, we have such examples. Maybe this is the answer of what's happening. But let's continue our analysis and let's see what will happen on the third week. I believe the situation will be the most obvious. So moving here, again, we're using the same data, but now we take our third week from production data. So here it is. And again, we build a regression performance report. So waiting for show method. There are a lot of visualizations, so it takes some time. And here it is. So now we see that our error is really high. It's much higher than the error we have on our reference data. And let's perform the visual analysis. We can see that now our predicted versus actual data looks not that good like on reference data. So let me a bit scale the axis. So now you can easily see that we really tend to underestimate the demand for our bikes. So this is not the diagonal cloud, right? It's a bit lower than the diagonal, which means that our predicted value is a bit lower than the actual. So let's continue seeing what's happening. And it's more obvious on this plot, I believe. Here we have prediction and actual values in time, and we can see that almost always our predicted values are lower than actual. It means that we tend to underestimate the demand. So let's try to analyze another plot. More or less same situation we can see on our predicted minus actual data, right? You can see that almost always we underestimate the demand. So all our values are below the green line, which is equal to 0. And more or less same we can see in distribution plot. So now it's even doesn't look like normal, right? So it's obviously shifted to the left part. So we tend to underestimate the demand. And let's try to figure out why it's happening. We already have a hint about seasonality and about temperature. And here again, we can analyze the table that we have in our regression performance report. This is the error bias, and this is quite interesting type of analysis. If we have the regression problem, then our model might be quite accurate, or it can underestimate or overestimate our target function. So we can separate such objects, I mean segment where we underestimate the target, segment where we overestimate the target, and see the distribution of values for each features. Maybe there will be some correlations or dependencies. And this is exactly what we are doing here. We analyze separately different kinds of mistakes and see how these mistakes related to feature values. So we split our errors into 3 types: majority, underestimation, and overestimation. And let's see what we have here. I suggest a switch off the majority because it's the less interesting segment, and see what is happening on underestimation and overestimation. And during our training on reference dataset, you see that our models made mistakes like underestimation and overestimation more or less on the whole amount of data. I mean, there is no specific shift. But if we analyze the data from our 3rd week, this is the current week, current data set, we can see that when we have smaller temperature, a temp, it feels like temperature. It's not real, but something that people feel when they on the streets. So we can see that we overestimate our target when we have smaller temperature, and we underestimate it when we have higher temperature. And this is more or less makes sense because in February it's getting warmer, right? And we haven't seen such examples during the training, and our model just doesn't know how to behave on top of this data. And I believe more or less same situation you will see on temperature feature. Yeah, yes, it's quite same. So now with help of such kind of visual analysis, we can get a hint of why our model actually gets such a lot of mistakes and tends to underestimate our target, our demand. So let's quickly see what's happening with our numerical target drift, because probably there should be really small p-value and we should be able to detect the target drift. Yes, p-value is equal to 0, so now it's obviously the distribution of our target during training, and current data is quite different. You can see it here, you can see it on the small plot there, so we have a lot of higher value of demand, right? And which we can visually see it there, so we never seen such high demand during the training, but on the current week, we saw a lot of such examples. And it's actually quite interesting to analyze the correlations, because now we see that there are a lot of differences in correlation between target and some features. So we can see that there are a lot of data where our correlations has changed, right? So, okay, interesting that prediction drift is not detected. So our model really cannot follow the trend, right? So it's behaves the same way how it behaved during the training, but it just doesn't suit and doesn't relevant to our current situation. So, okay, finally, I wanted to quickly introduce you the another type of reports, which is data drift, because, well, sometimes data drift can be used as early monitoring, and even before you can detect target drift, or you can detect the drop of performance of your model, you can notice some small changes in the key features and start thinking about preparing your model to changes in your data set. And data drift can help with this. In our case, I suggest us use only key features and its numerical features. So let's recreate column mapping and create the dashboard with reference and production data. But here I'm going to build a drift tab report. So that's how I do it, and I will quickly show you the results. And yes, even during the first week of our production data, we can see that the 4 features out of 6 numerical features are drifting. And this is exactly temperature, feels like temperature, humidity, and wind speed. So even after the first week of using our model, we can see that there are some changes in our data set. And this is the good hint for thinking about rebuilding the model. And we can visually analyze what is happening. Now we see that the temperature starts increasing. And for example, on the distribution plot, we can see that the higher temperatures start we can see such temperatures more often, right? So that's exactly what we can see here. So this is more or less I wanted to show you about model validation and model analysis. I hope guys you like how we can visualize the model performance, the data drift and target drift. And if you have any questions about using the tool or building the reports, I'm open to answer. And this code is publicly available, so you can follow the link. I hope we will share it with you very, very soon, maybe right now. And if you want to do same with your data or just work with our example, you can see this code on our repository. Yeah, thank you so much.
Thank you so much, Emeli. That was an excellent presentation. Maybe we should have scheduled like a 2-hour workshop so that we could have had people like follow through along with the lab. Thanks for explaining all the concepts. There are a couple of questions we can probably go with, and you mentioned that. And so the library is open source and free for anybody to use, right?
Yes.
Okay. And did you say that the notebook you mentioned was available on the repo itself, or?
Yeah, we have the examples in our repository, and this notebook is right here.
Okay, good, perfect. Okay, so I think there was another question. Your evaluation demo looks at the model error for monitoring. Does your software look at variance of the actual or numerical features themselves? Was the question.
I believe it was answered in the end because we showed this data drift report, which is basically addressing this view.
Okay.
So yes.
Okay. Yeah. So that's good. So are there any other questions? Okay. So my question was, okay, so I was looking at the wrong panel then. It's okay. Does it work for classification?
Yes, it works for classification. We have the classification performance report, probability classification performance report if you have probabilistic task. So it works for binary classification, it works for multi-class classification, but we have one limitation. It doesn't work currently for multi-label classification, where you have several correct labels.
Okay, got it. Okay, and so what's your vision for the project?
A lot of things to add. So of course, what we are using right now is a way to generate the reports. So of course, if you want to monitor the model that is running in production, it might not always be the most optimal way. So you can still use reports for debugging, but you also want to monitor it in an ongoing basis and to get alerts and to use it as a service. And that's the direction that we are working towards. And then we, of course, have a lot of small tweaks because we want, together with the community, to build the best ways and the best practices, how you can visualize and understand the performance of your models. And so we are very engaged in creating these new plots and adding some more interesting visualizations. Yeah. I'm personally very excited to look at it as a manager who always asks for similar questions every time Emeli sends something to me. We're very excited how we can present the inner workings of the model.
Absolutely, nice. And so currently, are you working with any customers, or is this deployed in production, or is it still?
It is free. Mm-hmm. It is free, so we have users, right? So we continue to develop it as an open source project, and we want to create it as a successful open source project. But of course, yes, there is a vision how we're going to evolve in functionality and add some more features which are more interesting to larger enterprises.
Nice. Cool. So thank you so much, Elena. Thank you, Emeli, for this wonderful presentation. I learned a lot, and I'm always, very appreciative of you taking the time, and especially with the time zone differences and everything, and joining us in today's session. I must also give kudos to the design aspects of what you've been building. I love the colors, the red and the white. So it's kind of, giving you the brand, the recognition there itself, but also the thought you put in terms of putting together all these graphs and the formatting and the ability to customize various things. So I wish you both the very best, and I hope our students and also the people from multiple countries, more than 10 countries are now have at least heard about your product now, and hopefully they're going to use it and use it in their products. And I'm going to see how the project evolves, and I hope the community also will support you in making this project successful. Thank you.
Thank you so much for your words.
Thank you.
Looking forward to it.
And next week, we'll see another presentation on how to build explainability dashboards. And the speaker is going to be joining us from Netherlands. So I hope to see you again next Tuesday at 12 p.m. East Coast time. Take care. See you. Bye-bye.
Bye.
Goodbye, everyone.